This is the third part in a four-part series that we decided to roll out, and it's a good thing we did. We've had a lot of good participation in this sessions. And it is basic training, just introductory stuff about Epitomy and how to get a system up and running, and the basics of connecting telephones, getting things working. And we've covered installation of telephones and trunks and basic routing to menus and extensions, and looked at some of the interfaces in the previous two sessions. We're going to repeat the previous two sessions because we have been trying to record them and have as of yet been unsuccessful in getting a good recording of either session. So what we're going to do today is we're going to do something a little bit new. We're going to hold questions for 30-minute break periods. So I'm going to try to keep myself timed here so that at 30 minutes I'm going to stop and then open it up for questions. Because what's been happening is people have been using the chat feature, which it's great, but what was going on was it was coming up in the middle of the screen that I was using to record, and obviously that screwed up the recording. So if you would hold your questions, keep them in your minds, and write them down, jot them down, or whatever, so that we can make sure to get them. I don't want to miss any questions. I want to answer your questions, so please make a note of them, and then at 30-minute intervals we'll take breaks, and I will go through any questions that you have. Okay, so today what we're going to cover, you can't talk about an IP phone system unless you talk about the networking, and we're not going to get real detail on the network, although I'm going to show you how to get detailed if you so desire. And in fact, certainly from a technical support standpoint, our group of guys here would love for you to be as knowledgeable on the local area network as you can possibly be. So becoming familiar with what's going on there and what's required of you is something that you should take on and that you should learn as well as what you get from us. And let me see where to take you for that. If you can probably start with something simple like wiki.epitomy.com and just wikipedia.org, and look up things like IP addressing and DHCP and some of the common phrases that you're seeing here. Today I've got a page that I've pulled up here just to illustrate in a way how much information is available to you out there. Certainly is a lot. I'm sure most of you probably know that. But there's a lot of good information available to you on the net. You can learn an awful lot just doing that. But the more knowledgeable you become in the local area network, the better off you're going to be in deploying and servicing your customers when they deploy IP products on that local area network. Then we're going to go through the security fundamentals overview, the access control list, log watch and ban service, time server, remote phones. We're going to configure a remote phone or two. We'll gladly engage any of you that wish to participate in that practice. I think it's a very simple. The connections of the system we've already gone through. I want to reiterate this again. And the reason that I want to do that is because you have to understand how systems are being deployed. When it's on an IP network, you're talking about devices that are not part of the Epitomy lineup. They are adjunctive devices that make the network operate. And the Epitomy server and Epitomy telephones and any gateways, whether you get them from Epitomy or somewhere else, they are all part of the devices that become appliances on that network. So it's very important to understand that distinction. We like the Netgear switches that you see here. This is an FS728TP, and I'm going to give you some information or point at that again, but it's a very inexpensive switch and it performs very well. There are better switches out there, and as network demands grow, you will want to have high performance switches that are capable of traversing multiple packets in a high traffic scenario. That's going to be very important. The connection, PRI lines is if you have a 1200 chassis or 2000 or 5000 chassis, you can connect a PRI trunk directly to the chassis. That is a direct link between the server and the PSTN, interfaced at the bus of the chassis. So that becomes something that is not on the network. When you deploy SIP trunks, you're going to be going in through your router, and that's coming in through the WAN port of the router to the LAN segment of the router, which then goes into the switches, and then from the switches, you're directing it to all of the devices that are part of the network. And here again on that, the other type of POTS line on the PSTN network that you might interface is a POTS line, and that would be interfaced through gateways. And the key here is that these gateways convert POTS lines into SIP. That's what's going on at this point. So if you're receiving analog trunks, you are attaching in them or connecting them to the IP platform by way of a gateway, and that's how they become SIP and become communications devices on the network. All right, so a network is a group of interconnected devices. All of them are hosts on a network, and it kind of replaces an earlier phrase that was known to be the nodes of a network. Host is really a better way to determine this because a host is something that allows interaction with other devices, whether that's a query, whether it's a web page, whether it's a gateway. It doesn't matter. There is something that is being hosted at that device, and it is interacted with by all of the other devices on the network. The segments of the network are all of these interconnections between the hosts. And a segment would even include the bridges and the routers and the switches. If you have those devices, typically you're going to have at least a router and a switch. But they become part of the segments of the network and the interconnections between the network hosts. Starting a very brief overview of what's going on, the router is probably one of the most important points on a network because a router has the distinction of being that point on the LAN that interfaces the WAN. And what's going on at the router is that it understands from a predetermined table of private addresses what belongs on the LAN and what belongs on the WAN. And that becomes very, very important because as we, for security purposes and for traversing multiple points on the World Wide Web and a private wide area network that you might have deployed. MPLS is another very common wide area network that's deployed today. And this, although it's private, it becomes a wide area. And the breakdown of what goes where on the network becomes very important because of the effectiveness or the efficiencies of LAN traffic. What you want to do and what routers perform for you is the ability to say what is local and what remains local and what is wide area and must be traversed to outside of the local area network. All right, switches become a very, very important backend, and switches are the bare minimum of what you would need. What we recommend is that you deploy smart switches at the very least. And if you're talking about being a professional installation company about deploying voice over IP products onto a local area network, there really is no excuse to use a basic switch that has no smart capability. And when we're talking about smart, we're talking about the ability to have quality of service settings. That is the entry point. You can certainly go beyond there and spend lots and lots of money on switches as well. But as I mentioned, the Netgear switch, the FS728TP, is a 24-port, fully PoE switch, and your cost is going to be about $350. It's not expensive. And it performs the function of allocating packets in terms of priority. And this is quality of service, which we definitely need to mention. This is a very critical part about deploying a network, making sure that voice traffic has priority over non-voice traffic. Now, the diagram that I've got here kind of separates the two areas. If you can kind of see what's going on here in the red dots, this area, in the best world scenario, I've got telephones that are isolated from non-voice traffic, which are the blue dots, by placing them on the switch so that they are connected most closely to one another without being impacted by traffic that is non-voice traffic. Now that's the best world scenario, and that's not always possible. So quality of service becomes a real important role in making sure that your voice over IP solution functions well. The other ports that we need to talk about here is the uplink port right here. The distinction between uplink ports is that it is usually two ports, one for the link to the one above it and then below it. And the distinction is that it is allocated for a higher level of bandwidth than are the other general ports on the switch. Where the other general ports might be 10-100 and automatically selected, an uplink port will start out probably at 100 megabits per second. And that would be kind of a minimum place to start. Usually with the copper connection in uplink ports, 100 megabits per second is where it begins. From there, you can go up to a gig, 1,000 megabits per second on a copper connection. At that point, if you're going beyond that, and let's say that these two switches are located in vastly separated areas, you can use fiber to traverse that area and deliver very, very high speeds as well. With fiber uplinks, you're able to go up to 100 gigabits per connection. And the sole purpose of this is to assure that the backbone of the network has the capability of delivering data traffic in the best possible means. Now, when we take this to the next step and add devices on the network, we have to identify them one device to another. And this is done with a MAC address. If you're not familiar with MAC address, it's just a machine address code, and or media access control code, and it is identified to every single device that is produced. Whenever a piece of equipment, whether it be a PC or an IP telephone, it doesn't matter what it is. If it's an IP camera that's going into video surveillance, all of them have a MAC address that defines the device as a unique device among all of the others. It is a device code that is given in 6 pieces, and an IP address. Well, if you are trying to apply an IP address to multitudes of devices, you can see that it's not a good thing for a human to be in control of. I would never recommend anyone to use static IP addresses for all of the devices on a local area network. And the reason is because it's very simple. If you're making a list today and now you have to go back sometime in the future, let's say 3 months from now, you don't know where the list is, and you don't remember who had the list, or was it updated last, or what was added to the network. It's literally crazy to try to think that we as humans are going to be able to properly administer IP addresses when there are multiple devices that might be applied to a network. And this is where the DHCP, or the automatic assignment of IP addresses, comes in. We recommend using DHCP in all cases for most of the devices on the local area network. The MAC address, which led us to here, is how the router, or usually the router. DHCP servers do not have to be based in the router. They can be deployed independently. A lot of people will use Windows servers to deploy DHCP. It doesn't matter. However you're deriving your IP addressing, we recommend that you do it automatically and use a DHCP assignment. The DHCP server recognizes a unique device by the MAC address. So if that MAC address has been assigned an IP address before, it will likely get the same IP address assigned again, unless that IP address has been assigned to something else in the absence of that MAC address on the network for some extended period of time. And that would be typically called the lease period, how long the DHCP assignment of that IP address would be associated to this particular MAC address. So when this comes down, then, you're talking about a lot of devices that are unique and must be addressed independently so that they can be addressed by all of the other devices on the network. What's important about how this comes into play is when we talk about the various devices and how they interact with the other devices. The IPitomy server down here at the bottom is an intelligent device which hosts the application of the PBX, and it hosts music on hold, and it hosts conferencing. There are several things that go on in this server. The same is true for the telephones. The telephones host a telephone application. And each of these telephones is a smart and uniquely independent device that can operate on itself. It doesn't necessarily need a server. But we're using this server as a culmination of the features that are to be presented to this telephone. So it's completely different from old world telephony. If you're coming from the TDM telephony world and you're now deploying IP, you have to think outside of the box because you're looking at something that is entirely different in the way that it communicates with one another. Where in the past we used to have centralized processing, it is now completely distributed processing. Processing occurs across the network, and every device receives its identity and says, okay, I am a unique device on this network, and this is what I do. And every other device is either going to interact with it or not based on its need. Whether the telephony application in the phone needs to get information from the server or not is a function of the telephone and its interaction between the telephone and the server. So that being said, there are a couple of things on this network that we want to have static IP addresses. And static IP means that it's a fixed IP. It is not automatically generated. We're going to assign it a specific IP address. The first would be the router itself. You want to make sure that the router is located on its own IP. And typically in this world, it's going to be a 192.168.1.1. Linksys set that out a long time ago. D-Link was trying to do zeros for a long time, but I think Linksys has won out overall. This is the default IP address scheme for local area networks. Now, that being the case, in my system that I take out in the field, the IP addressing scheme that I use is 172.29.20. And the reason that I'm using that is because I take this into multiple environments. And as you might imagine, when I take it into environments that are 192.168.1, I might easily have a conflict. And at that point, the router doesn't know whether to send the traffic to the LAN address or to the WAN address. If I'm connecting my router behind a 192.168.1 network, this will confuse the router, and it won't know where to send traffic. And you'll get varied responses by doing so. So I bring that up because I think it's a valid point to make that it is wise to change the local area network IP address to something other than the 192.168.1 network. But the router, the PBX server, and also the switch should be on its own static IP. And the reason for that is I can navigate to that specific device if I have an address that is associated to it. For instance, I'm using port 8080 to navigate to the switches in the test lab, and if I do that, if I have a static IP for the switch, it allows me to do programming on that switch. So now I'm into the FS728TP switch, and I can do whatever programming is necessary on that switch. Now, I have to be honest with you today, it's a very good day to illustrate this. I'm going to put in the password right here, and I'll hit login. I had a lot of trouble getting my Netgear switch in there to respond well to me. And this is one reason that you're going to have to become familiar with multiple browsers, not just one. But frankly, I tried all three of my browsers this morning, and I couldn't get one of them to respond well. I am not getting past, although I can see that I am navigating to the home screen. I am not getting a rendering of this page, so I'm probably going to need to reset that switch before I'm going to be able to see this screen. That is a very good reason that if you're using Mozilla Firefox, it's one of our favorites, but it's not everything. You're going to have to still use Internet Explorer on some occasions, which is definitely not our choice. Or the other one would be Chrome. I like Chrome a lot. A few people here don't like Chrome that much, but I do. I like Chrome a lot. The key is that you have to become familiar with multiple browsers, because you're going to experience different. You're going to have different experiences one browser to the next based on what you're viewing. When it comes to our system interface, I haven't had a problem using any one of these browsers. Our renderings on these pages come out pretty much the same on each of them, although they are different one browser to the next. And that's a normal anomaly with browsers. Okay, so I've just said to you to change the IP address. And I think that's a wise thing to do, but it's critical that you change it to something that has been allocated as a private network. And this is really easy to find out. I've got it right here in front of you. It's 192.168.0.0 through 192.168.255.255. Now you can see that I've got a whole lot of nodes that are possible in this one network address scheme. This is more than most people will ever have to use. And you can see by just putting it in as a one network, it eliminates it down to 254. Now I'm going to illustrate that by showing you a calculator. Let's see, Jody, IP calculator. This calculator I thought was pretty cool. Let's just take the IP address 192.168.1.1, and we'll say that the network mask is 255.255.255.0. If I calculate this, it tells me that I have possible nodes of 254 nodes. Okay? So the difference between what they show you in that definition of 0.0 becomes quite significant. Oops, got to open that up. Now you have the 65,534 possible nodes. If you were to open this up completely and allow for the full range of what's available in 192.168. Now, for a, all right, we're already at 30 minutes, so I got to take a little break here. All right, I'm going to open it up.